Hello everyone, welcome to my YouTube channel Code for AI and Data Science. I am Dr. Lakshman Singh. In this tutorial, I shall focus on building the heart disease prediction system using support vector machine, decision tree and LDA. To build the heart disease prediction system, I will use the heart disease dataset about which I will discuss later on as I begin the implementation part of this project. And if you are new to this channel, kindly subscribe this channel so that you keep on getting the new updates and content on AI in data science. Let's start building the model heart disease prediction system using SVM, decision tree and LDA. Here we will use MATLAB software to develop the heart disease prediction system. For this purpose, we will use three main machine learning classifiers such as SVM, support vector machine, decision tree and LDA. And before building the heart disease prediction system, let's understand the flow diagram for the heart disease prediction system, how the heart disease prediction system will be developed. Here we can see the heart disease dataset. The heart disease dataset contains the input features and the target levels. So we will first split the input features and target levels separately, and then we will split the input features and target level both into the ratio of 80 and 20%. The input features will be split into the training set and testing set into the ratio of the 80 and 20%. Similarly, the target levels will also be split up into the ratio of 80 and 20%. The 80% dataset will be used for training, while the 20% dataset will be used for testing the model. And this will be done for both, means input features as well as target levels. Means 80% of the data of the input features will be used to train the model, and 20% of data of the input features will be used to test the model. Similarly, from the target level also, the 80% of the data will be used to train the model, and the 20% of the data will be used to test the model. And here we will use the three classifiers to build this heart disease prediction system: the SVM, support vector machine, decision tree and LDA. So let's move to the MATLAB software where we will build up this system. Here you can see the three icons: home, plots and apps. You can directly go to the apps, and here you can see the multiple icons here: the classification learner, application compiler and sim biology, optimization and curve fitting. Means these icons are for the different application and different purpose. Here you can see the image acquisition. Whenever you want to acquire any kind of image, you can use this tool. Here we will use the classification learner. Here you can see the multiple tools here. Regression learner, for the regression purpose you can use regression learner, and if you have the time series dataset, you can use the neural net time series tool, and if you have the pattern recognition problem, you can use the neural net pattern recognition, and if you have any other dataset for fitting, then you can use neural network fitting model, and if you have the clustering problem, you can use the neural net clustering. And but here we will use the classification learner tool, as our problem basically belongs to the classification, so we will use here the classification learner. Now you will go to the new session and you will go to the from file, means you will upload or you will import the data by using this icon. And here we will first upload the dataset, heart disease dataset. Here you can see the dataset. You can see the basically the input features: age, sex and cholesterol, pain, the BP at rest and the cholesterol level, and the blood sugar while the patient is at fasting, and the ECG and the result of ECG while the patient is at rest. And here you can see the multiple input features. and last column represents the target level, and whether the patient is suffering from the heart disease or not is represented by the last column. 1 represents that the person is suffering from the heart disease, and 0 represents that the person is not having any disease. So here we can go through this means data set, and we have the multiple input features and one target level. And once this screen appears, we can import the selection. Now the data is available in the workspace of the MATLAB. Here you can see the target level. The target level is either in the form of 0 and 1, and we have the 12 features total, and 11 features are from the input, and the 1 features represent the target level. And here we have the total number of rows are 303, and here we will use the cross validation 5 folds, or we can use the 10 folds. Generally we use the 10 folds cross validation. And why do we use the cross validation? Cross validation basically shows how well our machine learning model can work on the unseen data. Means if we are using the 5 fold, then we will split the data into the 5 folds, and that means we will use the 4 folds to train our model and 1 fold to test our model. And if we are using the 10 folds, then we will split our data into the 10 folds, and the 9 folds will be used to train the model, and the 1 fold will be used to test the model. So this is cross validation is used to see whether our model can work perfectly on the unseen data or not. Here you add all the features and then start the session. Here we have disabled the PCA. PCA used for the feature reduction, means which features are important we can know by using the PCA, but here we have disabled the PCA. We are not using the PCA, principal component analysis. So we will be using all the features. If we are having the 11 features, then we will be using all the 11 features to train our model. And here we can use any, here you can see how many classifiers are there. Here we can see the number of classifiers. We can see the decision tree classifiers. We have the variety of decision tree classifiers: fine tree, median tree, coarse tree, and all trees. Similarly, we can use the LDA also, linear discriminant classifier, LDA, quadratic discriminant classifier, and all discriminant classifiers. Apart from these two classifiers, we can also use the logistic regression, and as well as the linear SVM, quadratic SVM, cubic SVM, fine Gaussian SVM, and median Gaussian. So here we can see the number of classifiers, but to build this model, we will be using only the 3 classifiers. Our focus will be on SVM, decision tree, and LDA. So you can choose the fine tree, and then you can train this fine tree model. It will take some time. It is taking a little bit longer time due to the slow processing speed. Here the model has been trained, and model has produced the accuracy of 72.3% with the prediction speed of 2500 observations per second, and it took the 5.75 seconds to train the model. And here you can see the accuracy is very low, 72.3%. and if you want to see the confusion matrix and ROC curve, then you will have to click on the confusion matrix. Here you can see the confusion matrix, and confusion matrix basically means these two cells, which are green cells, represent the true positive rate, and red cells represent the false negative rate. And what is the true positive rate and what is the false negative rate, we will understand through our PPT later on. And here you can also draw the ROC curve. Here you can see the ROC curve. ROC curve is drawn between the true positive rate and false positive rate, and through our PPT we will also understand what is the true positive rate and what is the false positive rate. Here you can see the AUC, area under curve. The area under curve is 0.76. If the area under curve is higher, if the value of this AUC is higher, then the model will perform better. And if this area under curve value is small, that means the model is not performing well, model performance is not good. So the area under curve shows simply the performance of model. If its value is higher, that means the model performance is good, and if its value is lower, that means model performance is not good. So this area under curve will simply show the capability of the classifier, means how well it is performing on a particular data set. So here we have seen the performance of decision tree. We can train other models too. For example, we can train the linear SVM. Here you can see the area under curve is 0.88%. That means 88%. If the model performance is 100%, its value will come out to be 1. But here you can see its performance is coming out to be 0.8%. Means it is better than the decision tree. So here you can see the 0.13. 0.13, what is the 0.13? 0.13 is the false positive rate, and 0.72 is the true positive rate. So in in our PPT slides we will discuss what is the true positive rate and what is the false positive rate, so we can easily understand the true positive rate and false positive rate. So next we can train the LDA. Here you can see its performance is comparable to the SVM. Its accuracy is 80.2% and its area under curve is 0.88%, which is quite similar to that of the SVM. Here we can see the confusion matrix, and we have obtained this result from the from MATLAB. Here we can see the green cells. What the green cells are representing, here you can see that the rows shows the true class and the column shows the predicted class. This confusion matrix, in this confusion matrix, the rows are showing the true class while the columns are representing the predicted class, means predictions done by the machine learning model. And here you can next see the diagonal cells show where the true class and predicted class match. If these cells are green, the classifier has performed well and the classified observations of this true class correctly. This means this green cell is simply showing that the true class and the predicted class are matching. Means 70% of the true class are matching with the predicted class. Here you can see the 78% of the true class is matching with the predicted class. And this here you can see the true positive rate, and here you can see the false negative rate. Means 70% of the cases have been correctly identified by the machine learning model, and in this means for the class 0, and for class 1 78% of the cases have been identified correctly by the machine learning model, and for class 0 25% cases have been missed. Basically means this is the false negative rate. False negative means 25% of the cases basically belongs to the positive class, but these 25% of the cases have been identified as a negative by the machine learning model. And for class 1, the 22% of the classes have been identified as a negative, while these 22% cases belongs to the पॉजिटिव क्लास. ये आपका 22% जो क्लास जो 22% जो आपका क्लासेज हैं, 22% जो आपके ऑब्जर्वेशंस हैं, बेसिकली ये जो आपकी पॉजिटिव क्लास से बिलोंग करती हैं, लेकिन आपके मशीन लर्निंग मॉडल ने इसको एज ए नेगेटिव आइडेंटिफाई किया है. सिमिलरली यहाँ पर हम देख सकते हैं फॉर क्लास 0 25% of these cases belongs to the positive class, while your machine learning model identified these cases as a negative. So these 25% and 22% will be the false negative rate. Here you can see the 75% means आपके मॉडल ने 75% केसेस को करेक्टली आइडेंटिफाई किया है एज ए पॉजिटिव, एंड फॉर क्लास 1 मीन्स 78% केसेस को आपके मॉडल ने करेक्टली आइडेंटिफाई किया है एज ए पॉजिटिव. So this is the true positive rate. We can further understand it means in more detail. Here we can see the true positive rate. The true positive rate represent the percentage of positive samples that were correctly identified as positive by the model. जैसा कि मैंने आपको अभी बताया कि आपका ये जो है जो ट्रू पॉजिटिव रेट है, इट रिप्रेजेंट द परसेंटेज ऑफ पॉजिटिव सैंपल्स विच वर करेक्टली आइडेंटिफाइड एज पॉजिटिव बाय द मॉडल। यानी कि आपका जो है परसेंटेज ऑफ पॉजिटिव सैंपल्स दैट वर करेक्टली आइडेंटिफाइड एज पॉजिटिव बाय द मॉडल। इसका मतलब क्या है कि आपका जो है तो मशीन ने, जो आपका मॉडल है, मॉडल ने मान लीजिए आपके पास में 100 केसेस थे और 100 केसेस थे, 100 जो टोटल आपके पॉजिटिव केस थे वो 100 थे, और 100 पॉजिटिव केस में से आपके मशीन लर्निंग मॉडल ने 75% केसेस को एज ए पॉजिटिव आइडेंटिफाई किया। दैट मीन्स द ट्रू पॉजिटिव रेट विल कम आउट टू बी 75%। क्यों? क्योंकि आपके टोटल नंबर ऑफ जो पॉजिटिव केसेस थे विच वर दी 100, एंड आउट ऑफ द 100 केसेस, जो कि आपका 100 एक्चुअल पॉजिटिव केसेस थे, आउट ऑफ द 100 पॉजिटिव केसेस मशीन लर्निंग मॉडल आइडेंटिफाइड ओनली द 75 cases as a positive. So the TPR will be the 75%. And here the false negative rate, it represents the percentage of positive samples that were incorrectly identified as negative by the model. यानी अब आपका जो है आपके पास टोटल नंबर ऑफ पॉजिटिव केस कितने थे डेटा सेट में? आपके पास में 100 टोटल नंबर ऑफ डेटा 100 टोटल नंबर ऑफ पॉजिटिव केसेस थे, जिसमें से आपका 75 जो है मशीन लर्निंग ने करेक्टली आइडेंटिफाई किया एज ए पॉजिटिव, लेकिन जो 25 केसेस थे वो मशीन लर्निंग मॉडल ने एज ए नेगेटिव आइडेंटिफाई किया। मीन्स मशीन लर्निंग मॉडल आइडेंटिफाइड दोज 25 केसेस एज नेगेटिव। तो आपका जो 25 केसेज हैं वो क्या होंगे? आपके फॉल्स नेगेटिव रेट होगा। फॉल्स नेगेटिव रेट मीन्स 25 अपॉन में 100, क्योंकि आपके पास में 100 टोटल नंबर ऑफ केसेज हैं जो पॉजिटिव केसेज हैं, तो आपके दिस 25 अपॉन में 100 विल come out to be the 25%, means FNR, false negative rate. So these terms are a little bit complex to understand, but we can easily, if we focus more attentively, we can easily understand these terms, true positive rate and false negative rate. Further, we can also understand PPV, the positive predicted values, and FDR. FDR is what? The FDR, false discovery rate, positive predictive value and false discovery rate. Here you can also compute the positive predictive value and false discovery rate. So what is the positive predicted value and what is the false discovery rate? The positive predicted value is nothing but the it shows how many are the correctly identified, means positive cases which have been identified by the model, means how many cases have been correctly identified as a positive by the model out of the total positive predicted cases. इसका मतलब यह है कि जितना भी आपका जो है मशीन लर्निंग मॉडल ने जितने भी केसेस प्रिडिक्ट किए हैं एज ए पॉजिटिव, उनमें से हाउ मेनी आर द करेक्ट केसेस विच आर आइडेंटिफाइड बाय द मॉडल एज ए पॉजिटिव। तो जैसे मान लीजिए आपका मॉडल ने आपका अगर जो है मॉडल ने मान लीजिए आपका 80 केसेस जो हैं एज ए पॉजिटिव प्रिडिक्ट किए हैं, लेकिन 80 केसेज में से जो कुछ केसेज हैं आपके जो कि सारे पॉजिटिव केसेज मीन्स करेक्टली आइडेंटिफाई नहीं किया मशीन लर्निंग है, कुछ जो केसेज उसमें जो आपके नेगेटिव भी हैं जो कि मशीन लर्निंग मॉडल ने एज ए पॉजिटिव समझ करके उसको प्रिडिक्ट कर लिया है। तो इसका मतलब जो भी प्रेडिक्शंस किए हैं, the predictions made by the machine learning model contains the positive cases as well as negative cases, but the machine learning model identified all the cases as a positive. तो उसमें क्या है कि आपका मशीन लर्निंग मॉडल ने जितने भी केसेस जो प्रिडिक्ट किए हैं, हमें ये देखना पड़ेगा कि कितना उसने करेक्टली प्रिडिक्शन किया है, करेक्ट प्रिडिक्शन कितना किया है, यानी पॉजिटिव केसेस को कितना सही से आइडेंटिफाई किया है। अगर आपके पास में यानी आपके पास में अगर मान लीजिए उसने 80 केसेस को प्रेडिक्ट किया, तो 80 में से आपके करेक्ट प्रेडिक्शन कितना है, यानी पॉजिटिव केसेस को कितना करेक्टली प्रेडिक्ट किया है, मींस हाउ मेनी करेक्ट पॉजिटिव केसेस आर देयर। सो इन FDR, आउट ऑफ द टोटल पॉजिटिव प्रेडिक्ट केसेस, हाउ मेनी केसेस आर इनकरेक्टली आइडेंटिफाइड एज ए पॉजिटिव बाय द मॉडल। ये शो करता है कि आपका हाउ मेनी नेगेटिव केसेस वर आइडेंटिफाइड एज ए पॉजिटिव बाय द मॉडल बाय मिस्टेक आउट ऑफ द टोटल पॉजिटिव प्रेडिक्शंस। जैसे मान लीजिए अभी मैंने आपसे कहा कि इसको हम एक बहुत बेहतर तरीके से इस तरह समझ सकते हैं, जैसे आपके मशीन लर्निंग मॉडल ने मान लीजिए 100 केसेस को पॉजिटिव प्रेडिक्ट किया है, लेकिन 100 केसेस में से आपके जो हैं केवल 80% जो हैं पॉजिटिव केसेस को करेक्टली प्रिडिक्ट किया है। यानी कि जो उसमें 100 में जो 100 प्रिडिक्शंस किए हैं मशीन लर्निंग मॉडल ने, हमने चाहा था कि मशीन लर्निंग मॉडल हमारे पॉजिटिव केसेस को प्रिडिक्ट करे, और उसने 100 केसेस को प्रिडिक्ट किया, पॉजिटिव केसेस को प्रिडिक्ट किया, लेकिन उसमें से केवल 80% केसेस ही करेक्ट हैं और 20% उसने जो है रॉन्ग प्रिडिक्शन किया है। तो इसका मतलब यह है कि अगर 80% केस प्रिडिक्ट हैं तो आपका 80/100, क्योंकि 80% केस 80 केसेस को उसने करेक्टली प्रिडिक्ट किया, तो 80/100 विल बी द पीपीवी। एंड 20% केसेस को उसने रॉन्गली प्रिडिक्ट किया, यानी वो 20% केस बेसिकली पॉजिटिव केसेस नहीं है, वो नेगेटिव केसेस हैं, लेकिन आपके मशीन लर्निंग मॉडल ने उसको बाई मिस्टेक पॉजिटिव समझ के प्रिडिक्ट कर लिया है, तो वो आपका होगा FDR, फॉल्स डिस्कवरी रेट। Here you can see the PPV, means it is the ratio of true positives to the total number of positive cases, total number of positive predictions made by the model. Here you can see the FDR. FDR is the ratio of the false positives to the total number of positive predictions made by the machine learning model. So here you can see the PPV and you can see the FDR. So here once again we understand what is the PPV and what is the FDR. PPV आपका जो है जो टोटल ट्रू पॉजिटिव्स हैं, जितने भी आपके ट्रू पॉजिटिव्स और जो टोटल नंबर ऑफ प्रेडिक्शंस हैं उसका रेशो है। यानी कि जितना आपका जो है जितने टोटल प्रेडिक्शंस हुए हैं, उन टोटल प्रेडिक्शंस में से कितना पॉजिटिव केसेस कितने करेक्टली प्रिडिक्ट हुए हैं, दिस इज नॉन एज पीपीवी। एंड एफडीआर का मतलब है कि जितने भी आपके टोटल प्रेडिक्शंस हुए हैं उसमें से आपके फाल्स प्रेडिक्शंस कितने हैं, टोटल प्रेडिक्शंस में से फाल्स प्रेडिक्शन कितने हैं, दैट मीन्स आपके ऐसे कितने नेगेटिव केसेस हैं विच आर incorrectly identified by the machine learning model as a positive cases. So here we end up this tutorial. Thanks for watching this video, and if you like this video, please subscribe this channel and also share this channel with your friends so they can also keep on getting the new videos on new topics. Thanks again for watching.